Hello, and welcome to the laboratory. Today, we're going to do Chem 120, molality. Molality, right? Little m. It doesn't have to be that little. Molality. And molality. So, okay. Welcome to Chem 20 on the board. Today, we're going to do molality. And I'm not going to do this voice anymore. All right, because I don't want to scare the students. We're going to talk about little m molality. Molality also has to do with solutions. It's not to be confused with big M molarity. Why did I put that up there? So that you don't get confused. Molarity is not little m molality. Little m molality is moles of solute, which is the substance being dissolved to make the mixture or solution, divided by kilograms of solvent, which is generally, in our case, the liquid mixture that we're adding. The solvent is what dissolves the solute. So unlike molarity, which is moles of solute, so that part's the same, but liters of solution, which is the total solution. This is just moles of solute by the weight of what you add to dissolve the solute. So let's take our flask. Whoa, it's got bad glass blower. But anyway, this is 250 or so milliliters, which means somewhere around here is 250. It really holds more than that, but we're going to put 250 in there and crank this baby all the way up. And then in the meantime, 250 mils of water is what we're going to put in this flask. And then we're also going to add 50.23 grams of sodium hydroxide. I'm asking the camera person. That's so great. Here we go. 50.23 grams of sodium hydroxide in here. We're going to put in 250 milliliters of water and fill this beaker up to like right here, this flask right up to here with water. It's going to dissolve the sodium hydroxide. But the question is, what have we made? We're trying to find molality. We've taken a certain amount of grams of sodium hydroxide, put it in a flask, then we've added 250 mils of water to that flask, we've mixed it up, it's all dissolved, so it's now a solution, a homogeneous solution because everything's dissolved. But we want to know something about how we can measure it so we can use it in an experiment. As usual, we have to start with our grams of something. And so we have the solute, which in this case is sodium hydroxide. We need to know how many moles of that there are because that's the factor that we have here. So 50.23 grams of NaOH. We're going to convert that to moles because 1 mole of NaOH is 39.997 grams of NaOH, and that converts to 1.2548 moles of NaOH. And then on the bottom of this entire thing, we're going to take the kilograms of solvent. But we don't have a weight of solvent. We only have a volume. So we have to know the density of our solvent, which is water. So 250 mils of water, we have to convert that to grams, but we know 1 gram of water is 1 milliliter. 1 milliliter weighs 1 gram, or 1 gram is 1 milliliter of volume of H2O. Right? So we're using our density as a conversion factor. So now we're in grams of H2O, but we want to be in kilograms. So we have to do that conversion, and kilograms are bigger, so 1 kilogram is 1,000 grams. And if we do that math, we now have 0.250 kilograms of H2O, which is the solvent. So we have our numerator and our denominator. Our numerator in moles of NaOH, our denominator in kilograms of solvent, which You do the math on that, and you get 5.023 molal NaOH. And let's check significant figures. We've got 4 and we've got 2. Right? Everyone see that? So 5.0 molal NaOH. Thanks for your time and patience, especially with the bad jokes.